This is a quadratic equation. Highest power of x is 2, and there are no rational powers of x, no like x to the 1/2 or anything like that. So I'm going to move everything over to one side. And I don't see a way to simplify the numbers nicely. Nothing goes into all of those coefficients evenly, 2, 5, and -3. So I'm just going to divide everything by 2 to start my quadratic algorithm. And then my average is -b/2. To do -b/2 in this case, I'm going to multiply b by -1/2 because b is already a fraction. So I get -5/4 for the average. So my equation becomes average squared minus, minus z squared. I wrote a plus, but it should be minus. Average squared minus z squared equals c. When you square that average, you get a positive 25/16. There we go. There's where I changed that plus to a minus. I need to add 3/2 to both sides and add z squared also to both sides. So that's what I did there. Then 3/2, when you change it to 16ths, you multiply the top and the bottom by 8. So that's how I got 24/16 there. Then you add 25 plus 24, you get 49. So 49/16 is z squared. Take the square root of both sides and you'll get z equals 7/4, plus or minus 7/4. And that tells us what our solutions will be. It'll be average plus z and average minus z. And our average was -5/4. So we can combine these two fractions and see if we can reduce anything. And we can reduce there. 2/4 gives us 1/2 for the first solution. And then -5/4 minus 7/4 will give us a minus 12/4, which can reduce to -3. Since these numbers came out nicely to just fractions with no roots, that tells me we could have factored at the beginning if we wanted to. It would be a little complicated. Not the easiest type of factoring, but you could factor it. This next equation is linear. The highest power of x is 1. So I'm going to multiply both sides by 100 to start out. That will get rid of the decimal, which makes this easier. So subtract both sides by 400. And then divide by -7. And you'll get, 28/7 we know is 4. So I broke the 2800 up into 4 times 7 times 100, and that reduces to -400. And then the last one is an exponential equation, but we're solving for the base. So I'm just going to take the cube root of both sides, which means raise both sides to the 1/3 power. I do not need a plus or minus on my solution this time because that power is odd and not even.